Open a standard textbook on mechanics or thermodynamics, and you might immediately feel like you're falling into a bottomless pit of abstract math. There's a biological reason for that reaction. Your brain is wired for survival, meaning it actively rejects information, like pages of disconnected formulas, that doesn't seem immediately useful to staying alive. The problem is that most classrooms treat the subject as a brutal test of rote memorization. You're told to cram symbols and constants into your head just to pass an exam. But you can bypass that defense mechanism. You can actually trick your brain into caring if you treat the subject as a playful game of intuition. To truly decode how the universe operates, you need to set aside the calculator for a minute and adopt a completely different mental framework. You have to learn how to think like a physicist. The first tool in this new framework is simple. Drop yourself right into the middle of the problem. Imagine you've just stepped into a bottomless tunnel drilled straight through the center of the Earth. Instead of looking for an equation, ask yourself what your body would actually feel as you jump in. Curious, which direction is gravity pulling you right now? As you fall deeper into the crust, are you speeding up or are you slowing down? By simply visualizing the physical sensation of that fall, you've already identified the forces at play. You know gravity is accelerating you downward, and you figured that out without writing a single variable on a chalkboard. Injecting yourself into the scenario takes a dry, static word problem and turns it into a dynamic physical space that your brain already knows how to navigate. The second tool relies on scanning that space to find what we call special points, the extreme edges of a system where interesting things happen. Think of a playground seesaw. The dead center is a unique anchor point. It's the only place where downward forces balance out perfectly. Now apply that logic to our Earth tunnel. The planet's center acts exactly like that fulcrum. You are pulled equally in all directions, making it a point of zero net force. Once you identify the physics at these extreme anchor points, you can use them to connect the dots. Calculating what happens anywhere else in the system becomes significantly easier. Breaking a massive, chaotic environment down into a few manageable anchor points is a highly effective shortcut for solving complex physical systems. That brings us to our third tool, pattern recognition. When faced with a new challenge, you simply ask, what is this situation like? Highly complex, unfamiliar scenarios almost always share the exact same mechanics as mundane, everyday situations. For instance, you might be asked to verify the safety forces acting on a state-of-the-art fairground bobsled track. Calculating the force required to keep a bobsled on its track is ultimately about tracking how variables like speed and curve radius interact. This is the same logic used to calculate pizza delivery times based on distance and vehicle speed. Once you can model how one variable dictates another, you can solve both. Spotting these hidden analogies lets you take the logic and equations you already understand and map them onto completely alien environments. When you treat the subject as a massive exercise in analogy, the entire world becomes your personal reference sheet. Which raises an obvious question. If physics is entirely driven by intuition, imagination, and analogies, why do we bother with all the complex math? Equations function as the universal language used to document the physical intuition you've already constructed. A mathematical formula is an efficient tool. It allows you to make concrete, precise predictions, but the core understanding of the problem happens before you ever pick up a pencil. Standing atop this globe of terminology illustrates the final result. Applying this intuitive lens converts academic theory into a permanent cognitive upgrade that changes how you process reality. Learning physics is a process of acquiring a multi-sensory lens. It takes a terrifying wall of numbers and turns the universe into a puzzle you actually want to decode.